Good morning, class. Today we're going to talk about permutations. So we want to just introduce the topic of permutations. A permutation is an arrangement of objects in which order is important. So for example, a president versus a vice president would have different roles. When I'm looking at books on a shelf, if I'm putting in alphabetical order or random order, the order matters. Okay, so couple different options with this. A lot of times you'll see examples like see how many numbers you can come up with the digits 1, 3, and 8. What you'll be able to do with these options, because there are not that many of them, is list them out and find what it is. Then we can kind of use a modified counting principle here. For the first number we had 3 options. We've used 1, we can't replace it, so then we have 2 options. We've used now 2, so we have 1 left. And so you get 6. Okay? But we could also do this in terms of permutations, and we'll do that in a little bit later. Again, with 4, you could still list them out. That wouldn't be too hard for us. So that would be, you know, A, B, C, D, A, B, D, C, A, C, B, D, and you could list them out, but again, that's going to be a little time consuming. So we can set these up as permutations. So for this, I'm choosing from 3, and I'm choosing 3. In order to do that, what we're going to do here is, let me just add a little space here. We would put 3 factorial, and I'm going to explain what factorial is in a second, over 3 minus 3 factorial, which is 3 factorial over 1, because 0 factorial is 1. So this would just be 6, and the same thing up here. So factorial is like this. You start with that number and go all the way down to 1. 3 factorial, 6 factorial, etc. In this example, we're choosing from 4 possibilities, but we're only choosing 2 at a time. Again, using the counting principle, you could just do 4 times 3, but using permutation notation, we're going to put 4, because we're choosing from 4, a group of 2, and it falls into this category, NPR. No, not National Public Radio. So what you do there is you do 4 factorial on the top, and then you do 4 minus 2, which in this case is 2, and then you can simplify. So this would be sort of the general formula for a permutation. So for this, we're going bowling, and we have a group of 7 people with us, and we're wondering how many different ways can I line them up into groups of 5 where the order matters. So it'd be 7 factorial over 7 minus 5 factorial, which is 2 factorial. I try to simplify, and then we go to there. If you want to use the counting principle idea, you would just write out starting with 7, going down 5 spots till you get to 3, and you'd multiply it all together. Famous example that I like to use is talking about a president, vice president, and secretary for a class from 18 students. What is the number of arrangements? And again, in these jobs, their job description, they have different jobs. So it matters which position you are. So in this, it's 18 factorial, because we're choosing from 18, and then it would be 18p3, because we're choosing only 3 spots, and 18 minus 3 is 15. Let me just fix that up. So that this 15 factorial basically cancels out all the stuff remaining. So you'd only get 18 times 17 times 16. Using the counting principle idea is also a good idea for this as well. That's me writing it out. And the last example, This is you're choosing from 7 people, groups of 2, where order matters. Counting principle, 7 times 6, that's probably the most efficient. You could do 7 factorial over 7 minus 2 factorial, which is 5. And then you would get this. You get that same 42. Have a great day.